Assalamualaikum warahmatullahi wabarakatuh. Hello, greetings from me. My name is Muhammad Abdul Haq. I'm from Politeknik Elektronika Negeri Surabaya. Here, in the first conference on Internet of Things and Embedded Intelligence, or CITEI 2020, I will present my paper titled Improving the Speed of Ball Detection Process and Obstacle Detection Process in ERSOW Robot using Omnidirectional Vision based on Robot Operating System. Okay, before we start further, this is my presentation outline. There are introduction, the problems, limitation, and purpose, ERSOW's condition now, and the flowchart, and how I improve the speed process, and the last is reference, and then conclusion. This is the introduction. This research delivers a novel approach for improving the computation speed of the ball detection and obstacle. The speed condition of obstacle detection and ball detection in our robot still have a slow processing speed. This condition makes the robot not real-time, and the robot's movement is hampered. To build a good world model, things to note are obstacle information and real-time ball detection. The focus of this research is to increase the speed of the process of the ball and obstacle detection around the robot. To increase the speed, it's necessary to optimize the use of the OpenCV library, push library, and implementing ROS. And then minimize the use of too many frames. This information will be sent to the base station and also for obstacle avoidance purpose. Okay, we have three problems before we go. The first is how can robot detect ball and obstacle at high processing speed, and how to integrate the ball and obstacle detection program into ROS. And the last is how to send ball and obstacle information to the base station. We have two limitations. The first is the sensor used in this research is camera with omnidirectional, and the second is this system using ROS. The purpose of my research is robot solver can do the ball and obstacle detection at high processing speed, and the ball and obstacle detection can run using ROS, and the robot can send ball and obstacle information to the base station. Before I go to the result, this is the ERSOW's condition before I did the research. This is program running, and the process speed of Omni is obstacle is 67 and 42 in ball. This is millisecond. Okay, we have a flowchart. The first is input. We have input omnidirectional camera, and then I processing it with the thresholding and the other method, and the output is X and Y and theta of the ball and obstacle. And this is the tools and environment for my research. The first is laptop and omnidirectional camera. This is the camera view, and also the robot and the field. The processor used in this laptop is Intel Core i5, and RAM is 8 GB, and we use NVIDIA in VGA, and we use SSD, and we run using Linux Ubuntu 16, and the ROS version is Kinetic. So this is the ROS topic picture in my research. We have some program, but we focus in this Omni ball and Omni obstacle. This is ball detection program, and this is obstacle detection program, and this is the input of the program. We have Omni camera as an input, and then processing it and add with odometry, and then send into the base station. So this is how I improve the speed process. This is a picture of how my robot do the ball detection and obstacle detection, and how I improve it. In the first is ball detection. I simplifying the processing using ROS. So the program is break into some program so the program can maximizing the speed, and then maximize the use of region of interest, and then optimizing the frame. And then how I improve the obstacle detection. The first is simplifying process using robot operating system. I break into some program, and then maximize the use of region of interest. And then is inverted contour. We can see the picture in the center. We can see the black. This is the obstacle, and then I inverted it, so it just using one line to run this inverted contour. And the last is optimizing the frame. So this is the result, but the program is showing the frame, so the speed is still slow. The process speed is 52. It indicates that the improving of process speed at fault detection is in fault detection is still good. Okay, next, this is the program of obstacle detection. We can see the obstacle detection is still good after I improving the speed process. Okay, this is the final result of my research. I have using ROS, and this is the result. We got 17 millisecond in fault detection, and then 23 millisecond in obstacle detection. I think this is the good progress for our robot, so the robot can do the obstacle detection and fault tracking very well. So this is the graphic of increasing speed by progress. I using ROS and maximizing region of interest and frame optimizing. And this is the graph of increasing speed of obstacle detection program. So the conclusion is, based on the result of tests and analysis that have been done, it can be concluded that the speed of the process of the testing ball, which was previously 42 milliseconds earlier, become faster. This is 17 millisecond or 16 millisecond. And then the speed of process of detection, obstacle detection, which was previously 67 millisecond, become faster. That is 25 or 23 millisecond we can see before. And the program is successfully applied in ERSOW robot using robot operating system, and information from the base station, information from the ball and obstacle detection can be sent to the base station. So this is the reference when I did the research, but not just 7. There are 27 or 28, I think. Okay, that's all of my presentation. Thank you from me. Assalamualaikum warahmatullahi wabarakatuh.